Question 20. N is an integer such that 3n plus 2 is less than or equal to 14, and 6n divided by n squared plus 5 is greater than 1. Find all the possible values of n. Hence, my first step is to solve my linear inequality and my quadratic inequality separately and then put them together. As I'm solving for n, my first step is to move the plus 2 to the side by doing the opposite. Opposite add 2, therefore subtract 2 from both sides. On the left-hand side, 2 take away 2 will cancel to leave us with 3n on the left-hand side. It's still less than or equal to 14 subtract 2 gives us 12. I know 3n in algebra means 3 multiplied by n. The opposite times by 3. Therefore, divide both sides of my equation by 3. On the left-hand side, 3 over 3 will cancel to leave us with n. So n is less than or equal to 12 divided by 3 gives us 4. Solving my quadratic inequality, I know the opposite divide is to multiply. As I've got two terms, I'm going to place that inside single brackets. On the left-hand side, I'm just going to be left with whatever's on the top, in this case 6n. And that's greater than. On the right-hand side, I know 1 multiplied by n squared plus 5 will just simply give us n squared plus 5. As I'm getting a quadratic in terms of the letter n, and I've got positive n squared on the right. Therefore, I'm going to move the 6n across the right by doing the opposite. The opposite adds 6n, therefore subtract 6n from both sides. On the left-hand side, 6n subtract 6n will give us 0. So I've got 0 is greater than. On the right-hand side, I've still got n squared. I've got the negative 6n that's come across, and I've still got the plus 5. As my quadratic is less than 0, I'm going to write that as n squared minus 6n plus 5 is less than 0. Well, less than 0 is where my graph is below ground. Hence, my first step is to put my quadratic equal to 0 and solve for n. As I've got a quadratic in terms of n, I've got 3 terms. In this case, I can see I can factorise it. So 3 terms is going to factorise into double brackets. As the quadratic starts n squared, each bracket starts with a single n. I want to find 2 numbers that multiply to give us the number term, in this case positive 5, and the same 2 numbers must still add to give us the number in front of the single letter, which in this case is negative 6. In this case, my 2 numbers is negative 1 and negative 5. As I'm solving, I place each bracket separately equal to 0. If I put n minus 1 equal to 0, opposite minus 1 is to add 1. Therefore, one solution is n is 1. If I put n minus 5 equals 0, opposite minus 5 is to add 5. Therefore, my other solution, my other root, is n equals positive 5. As I have my 2 roots, and I want to find where the graph is below ground. Well, here, my 2 roots, in this case for n, is going to be positive 1 and positive 5. So positive 1 and positive 5. As n squared is positive, therefore I know it's a parabola, i.e. a U shape. I can see my graph is below ground for this region here, and my graph is above ground for this region to the left and this region to the right. As I want when my graph is below ground, i.e. less than 0, it's one region, so it's one inequality. So in this case, it's n. It's greater than 1 and less than 5. As we know n is an integer, the only integers that are greater than 1 and less than 5, in this case, are 2, 3, and 4. As our values of n, 2, 3, and 4, also satisfy our linear inequality that n is less than or equal to 4, therefore all the possible values of n that satisfy both are actually 2, 3, and 4.